panel. So Brunel Hydrogen is Brunel's newest research centre. Been going about a month, if that. We're incredibly pleased to be here because we're now part of this community of research centres. Brunel Hydrogen's strapline is thinking differently in hydrogen. Why do we do that? Because there's a whole range of areas where Brunel can contribute to activities in the hydrogen economy that other people aren't. We in hydrogen are not Imperial or Cranfield, we never will be. The question is, where can we play, where should we play, and where can we make a difference? And that's what we're working on. So we'll cover in Brunel Hydrogen not just research, but training, impact, and providing an independent public voice in the hydrogen economy. You may hear some of that just now. So hydrogen is an essential part of the transition to net zero. And it is, of course, technical, social, political, it's everything. This session starts us off thinking differently, a reality check on the hydrogen hype. The panel members are some of the 20 founding members of our new Brunel Hydrogen Research Centre. We have Professor Colin Axon, Professor Zhao, Professor Justin Fisher, and Professor Savvas Tassou. I'm not going to go into details about CVs or anything like that because that's not what we're here for. So I'm going to ask them some questions, we'll listen to their answers, and then I'm very happy to open it to the audience for further questions. So Colin, can I start with you? This session is about hype on hydrogen. There's lots of hype out there on hydrogen for everything. What uses do you see as a reality in the shorter and the longer term?
Thanks, Averil. First of all, I'll pick you up on saying essential for net zero. I'd actually say, well, we can show, and you can pick up a copy of our report, that net zero is physically impossible. And trying to pursue it will lead us down pathways which are really not very helpful and are extraordinarily expensive. But near zero, if you relax the constraints a little, may be possible. It'll still be eye-wateringly expensive, currently about 50% more than the current defence budget every year indefinitely. However, if you're going to do that, hydrogen will be necessary. And it'll be necessary in various technical elements to make that happen. One is internal combustion engines, but for trucks and other heavy-duty vehicles. Quite possibly home heating, though that's not necessarily the major player, but the principal one will be to smooth out, to use as a store, to smooth out the wrinkles in renewables production, or electricity from renewables, which are intermittent, and we don't lead intermittent lives, we lead quite predictable lives. So one way to do that, because you can burn hydrogen perfectly happily in a gas turbine, needs modifying, but it's entirely doable, that you make hydrogen whilst the sun shines and the wind blows, store it so you can use it across seasons, and then run that back through gas turbines that are co-located with the store, which are then producing the electricity. And that's the key way that you can get towards net zero in a technically feasible way, albeit very expensive.
Thank you. Hua, can you give us your view on which hard to decarbonise applications you see as most active at present and why?
Okay, thank you. I think I probably I will start by saying why hydrogen, because whenever we talk about the hydrogen for transport, for example, we use hydrogen for trucks and for buses, and people say, why don't you just use electricity? You can just connect to the electricity. I said, the reason we use hydrogen is not because we want to use hydrogen, because if we're going to have a renewable energy for the future, sun or solar or wind, they are intermittent. So you need a form of storage So you can actually store unused electricity. So we're not going to use electricity to produce hydrogen and then use hydrogen to produce electricity and then use it for other things. So that's the first thing I want to say. Second is, in terms of the most hard decarbonization sector, in the case of transport for long-haul heavy duty, you cannot use batteries because the weight, the cost, the volume, the charging time. And also for marine applications, you can't carry a battery, otherwise you can't carry any cargo because of size, volume, and charging time. And even for power generations, actually there's an increasing demand for data centers, so you can use hydrogen to generate power. So that's the second point. Third point is, now we have a technology which is more sustainable and affordable for the use of hydrogen for these sectors, for heavy-duty truck or marine or power generation. Because whenever we say hydrogen, people say, oh, fuel cells. But in fact, if you use internal combustion engines with hydrogen, it's much more affordable than fuel cells. It's more reliable, and it can burn hydrogen, any type of hydrogen. You don't need to purify the hydrogen. And you have a supply chain, because you just make use of existing supply chain. And you have a service industry as well. So it's a very sustainable way to decarbonize heavy-duty applications through the use of hydrogen internal combustion engine.
Thanks, Will. So Justin, out of the 4 people on the panel plus me, you're the one who's not an engineer, and that's really important. So all the hydrogen discussions you tend to hear out there tend to be around the technology, the engineering, but people are absolutely key to making any difference, to making things actually happen. What do you see as the social drivers and the social barriers to acceptance of hydrogen technologies?
Thanks, Averil. You make a really good point, because one of the problems with a lot of technological development is the assumption that if we build it, they will come. And actually, particularly when you think about hydrogen, even though it was 100 years ago, most people's recollections are around the Hindenburg. And so what you have there is instantly a problem with people's perceptions of this as a power source. However, there is a fair bit of evidence out there that suggests that some things are more likely to make people embrace the technology and accept it, whether that's accept it in terms of its operation within their communities or accept it in terms of the generation of hydrogen. And these are fairly sort of day-to-day reasons. For example, are the communities themselves going to benefit from the introduction of hydrogen? If there are hydrogen plants, will it be local workers who will benefit? What we have to avoid are things like fly-in, fly-out workforces. But also what the evidence suggests is that if people see hydrogen in operation and in operation safely, they are more likely to get behind its use. And that's typically very day-to-day things like refuse vehicles, but particularly buses, where you can use day-to-day technology that shows people this is not something that's about to go boo and can deliver benefits for the whole community. It's the sort of thing that really makes a difference. And then the third thing is simply trust. It's trust in science, it's trust in government, and it's trust in the technology. And we can't assume that those things exist. So one of the things that we're seeking to do is find ways in which we can go out into communities and demonstrate from a trusted provider, like the university, that this sort of technology will benefit local communities and help them embrace the technology.
Thanks, Justin. So Savvas, international perspective, how is hydrogen genuinely helping communities internationally, those particularly with limited energy access?
Yeah, lovely, thanks. Now, one of the greater challenges for decarbonization in developed countries really is the decarbonization of heating, because we mainly rely on the use of natural gas for heating. And if we have to decarbonize natural gas, then we have to look at alternative fuels, and of course, hydrogen is one of those fuels. Now, the global warming, though, it also generates really the requirement for cooling, because as we insulate the houses more and more, and we build more dense housing, for example, in the UK, then we increase the need for cooling. Now, in the developed world, then cooling is almost non-existent, really. But the temperatures are much higher, and therefore, really, the improvement of standards of living, and to increase the standards of living, then we need to provide cooling. Not only cooling for the occupants of buildings or for commercial buildings, but also really for the transportation and the storage of foodstuffs. So hydrogen can be used both for heating and cooling, particularly really in places where we can generate hydrogen with renewable energy sources. Because if we use, for example, electrolysis to generate hydrogen using either wind or solar energy, then we have really a source of fuel that we can use to provide both heating, but particularly cooling, and make cooling more accessible, so that we can increase productivity and also reduce waste of food as we transport it around the various sort of countries, the developing world, but also enable them to export to developing sort of countries to increase their incomes. Now, we can use hydrogen with new technologies in closed systems or open systems to provide both heating and cooling. In other words, replace conventional air conditioning systems that rely on refrigerants that can cause global warming and ozone depletion potential. Then a risk we have removed those, but we have the global warming aspects if refrigerant leaks. So research really, we direct now research into developing those sort of environmentally friendly solid-state systems really to provide heating and cooling in developing countries, where really we can use solar energy or wind energy to produce hydrogen and distribute it where needed.
Thank you. In just a moment, I'm going to open questions at the floor. I don't know whether we have a microphone or not. If we don't, you'll have to stand up and shout, oh, it looks like we do. But just before that, I'm going to ask all of you a quick question that I haven't briefed you on. So we have the spending review coming up. What one thing would you like to see the government do that would improve hydrogen use and development and making a difference? I'll start with you, Savvas, and we'll come back this way.
Or fund more research.
That's a perfectly valid answer.
Tax incentives for businesses to invest.
Yeah, I would agree. I think Japan has just taken the decision a few days ago to provide subsidy for hydrogen. So the cost of hydrogen will be in line with diesel at the pump. That would enable the users to start using hydrogen. I think that's probably the most important incentive we need to consider.
I think so there's something called the National Infrastructure Commission, and there's one in Scotland, there's one in Wales, and there's a national one as well. And we've talked to one of these bodies, and they're very interested, but as Averil said, the level of knowledge within these bodies is actually quite poor, or they've got some vague sense. So I'd like central government to have a much stronger incentive program of work to think about the infrastructure that is needed, because there will need to be modest amounts of additional infrastructure, whether it is to fuel trucks and buses or to use for storage to then to produce electricity. There is additional infrastructure that is needed, and that needs to be funded somehow. and the electricity markets, the electricity pricing mechanisms are, how can I put this politely, charmingly chaotic. Actually, not so charmingly. And that is leading to utterly perverse incentives and increased costs. And it's not really the price of gas that's driving it at all. It's actually the subsidies, levies, and various other support given to renewables, which vary considerably. And some of that is not actually very well directed and could be better directed towards looking at hydrogen infrastructure.
Thanks, Colin. Again, just a moment before I open questions to you, the audience. One of the things Brunel Hydrogen is trying to do is bring together lots of different disciplines, engineering, social science, but also creative arts. Why do we want to bring creative arts in? Because artists have an imaginative capability that, to be honest, most engineers don't reach. And bringing in their ways of thinking and ways of looking at things is one of the things we are starting to do. And at the Brunel Hydrogen stand in the other room, we have our first output of that. It's a hydrogen film. It's about 8 minutes long. It's set in a hydrogen-fueled future, looking at how we got there from where we are today. It is, of course, fictional. It's very interesting. I think there's quite a lot there it's worth having a look at. So, can I ask any questions, please, from the audience? There's a lady over there. I can't hear you. Do we have a mic?
We do have a mic, but no one to hand it around.
Oh, okay. Thanks, Seb. You have to run, Seb.
Oh, I've not agreed that.
Keep your feet.
Can you hear me now?
Yes, you can.
You quite rightly talked about storage of hydrogen, but how are we going to store it, and will that need other elements to be able to store it? And the other question that I want to just put in is, I understand water vapour is a byproduct of using hydrogen, so how are we going to catch that to recirculate? Because although we've got a rainy day today, we are actually got a water shortage to the country.
You.
I can take both of those. The first one, the reason for not wanting to put it on ordinary cars, passenger cars, is to get rid of the need for that storage. For the large grid-scale electricity production, you can use salt caverns, which we have an abundance of. We have quite a number of in the UK, and that's how we would do it. As for the worrying about the water vapour, I'm not worried about the water vapour.
Savvas, can you just make a comment? Because on the Brunel Hydrogen stand, we've got a little sample of some material that acts as a hydrogen storage. You can come and see.
I mean, there are different ways really to store hydrogen. You can store it as high pressure gas. You can store it in liquid cryogenic temperatures, or you can store it in metal hydrides. And then you can use that for other purposes as well, for heating, cooling, a combination of those sort of uses. And what we are trying to do really is to maximize the use of hydrogen, use it for different uses, heating, cooling, storage. And at the same time, I can use it even in aviation sort of applications. Heavy-duty vehicle sort of applications and so on. So you can, and that's where we're working on heating and cooling, because we can use it, once you have hydrogen really, then you can use it for different applications.
Thanks. Other questions?
Thank you. I'm Tassou from Brunel as well. Well, I'm not against hydrogen.
We can't hear.
A bit closer to your boss.
I think it's on now. Is it?
Yeah, that's
Yeah.
fine.
I'm not against hydrogen, but this is, if you like, devil advocate questions. You mentioned, of course, batteries and large vehicles, and they can be only done by batteries. But if you look at the history of development of batteries, at the beginning, we used to have batteries going for 15 miles on a car. Now we got 600 miles. So why do you think that by the time hydrogen becomes developed, batteries are actually used in heavy goods vehicles? We are going to solid state batteries. And with the mention of gas turbines as well, as a backup, gas turbines actually burning gas are going out of business at the moment because they are not actually running as a profitable business model, because they are not running all the time. They're just running as backup, stop, start, and they're not making economic sense. With hydrogen having a much worse round-trip efficiency, how do we think that in the future it will make sense if it cannot make sense now?
Well,
Yes, a couple of questions. Why use hydrogen, not batteries? If you take China, for example, they use batteries, but how much energy they use to produce batteries? If you do a life cycle analysis, I can tell you, if you drive a passenger car, if you use Chinese electricity, you need to drive 150,000 miles before the CO2 is less than the gasoline car. That's the current situation. But the more important thing is, in fact, the electricity generated by wind and solar cannot be used. In China, again, I use the example, they have installed more solar and wind capacity, electricity generation capacity than coal. But they can only use 20% because they cannot store the energy. So the reason is because you have to store the energy in the form of hydrogen. Therefore, you have the hydrogen. That's why you use hydrogen. It's not for the sake of use hydrogen, not the electricity, but because if you don't use hydrogen, this electricity will be wasted. So there's no efficiency involved. You're basically talking about wasted energy. So that's, in terms of technology, again, the battery, you say 600 miles. Again, I can tell you, all the vehicle manufacturers in China, the new so-called new energy vehicle, do you know what they are doing? They're adding engines now because they still can't solve the problem of the size, the cost, and the range. So they're actually going back to the engines now. So it's not as publicized because there's a lot of trade-off in terms of long range and the charging time, the cost. For inner city driving, it's perfect. If you have clean electricity, short range, that's perfect. But if you're going to have a long range, heavy duty, it's not suitable.
thanks, Warren.
Can I
Yes,
add
please
something?
do.
The environmental degradation and pollution caused by the mining of the minerals required by batteries is truly unspeakably horrible. It's absolutely terrible. And it's, for us in the Western world, it's out of sight and out of mind, but it's absolutely terrible on a human and an environmental level. As for your point about the hydrogen turbines not yet, the market is not functioning for them, you're right, but it's not a technical problem, it's a market problem which is intrinsically fixable with policy. And it's not something that we should actually let go, in my view.
Gentleman here.
Sorry. Yes, Stephen Aitken, part of the Borg group at Brunel. Hydrogen has a very small molecule which causes it to leak. Where is the problem, or do you just have to tighten the compression joints?
Yeah, again, I can share you with our experience. We were the first university who have set up the hydrogen supply and the hydrogen engine testing facility. So when we started, we have to jump through a lot of hoops. But in fact, for the last 3 years, we never had any leakage from hydrogen because there's ready pipes and the fittings you can buy off the shelf. And if you do it properly, it's not a problem. So in our lab, nobody is talking about hydrogen anymore because people get used to it. In fact, hydrogen is safer in the sense if there's any leakage, as long as you have plenty of ventilation, the hydrogen would disappear much faster than gas. So if you have natural gas or you use LPG, they tend to stay around. But with hydrogen, it just disappears. And as long as you have ventilation, it's very safe.
And I'll add to that, at the grid scale, the national gas grid, there will be some leakage, but as Hua's just said, within a minute or two, actually every free floating hydrogen molecule is out into inner space. When we had iron gas pipes, that was hydrogen would be a problem in those because it makes them brittle and it will just find its way through. Although it's not quite a smaller molecule, it's a small atom, but the molecule is larger. However, with the new polypropylene pipes, yes, there's some leakage at joints, but it's pretty minimal because actually methane is also quite a small molecule.
So we're reaching the end of our time. I'm conscious that you only said your piece. Have you any comments on the questions that have come up in terms of the people side of things?
Well, I mean, in a way, the previous question illustrated my point that there are lots of concerns about the potential safety of this. And this is why any rollout of the kind of technology that my colleagues have spoken about has to focus on demonstrating to the general public that it's safe, that it's useful, and that it will benefit them. That seems to me the forgotten part of a lot of new technology. You only have to look at wind farms and people's objections to those to understand why, if we want hydrogen to work, you need to work with communities, not simply impose it upon them.
Thanks, Justin. Thank you very much, everybody, for listening. We do have the Brunel hydrogen stand in there. Please do come and see it. And can I thank the panel, please?